So in this video, I'm going to attempt to show you the same thing as I've just done with the pen and the pencils, but diagrammatically, and it's an attempt to explain why, when you're going around the y-axis, a rotation around the y-axis, why does that have different signs to what you might expect? It actually is all to do with our friend the law of alternating signs, which you came across when you did what we're doing, inverse matrices. Okay, when you have to do the matrix of factors and the cofactors and minors and all of that kind of stuff, and you come across the alternating law of signs. I remember some of you asking me about it. It's all to do with that, basically. And to be honest, I could stop there. And if you're happy enough that the alternating law of signs is a thing, and that's why the y1 is different, you see how the x and the z rows are the same, but the y1 appears different. Well, that's fine by me. But I'm going to attempt to take you through what's going on here. So when you rotate around the x-axis, it is important to have a concept of what is meant by anti-clockwise, and it turns out that anti-clockwise is moving the y towards the z. So you're going around the x-axis this way. Note that step 1 in the x direction is still a step 1 in the x direction after you've rotated. If you're going around the x-axis, that any point on the x-axis is invariant. But notice that once you've rotated it, the y-axis was pointing straight up, but now it's coming towards us, which is the same as a step in the z direction, isn't it? And when you rotate this around, the z-axis, which was coming towards us, is now pointing straight down, which is the negative y direction. So if you put these together, you get this matrix here. This is just an example of 90 degrees, but you should notice where the minus signs are. If I ignore the first row and first column, the minus sign is in the top right, as it should be when I compare it to the rotation matrix that we're expecting. Okay. Now same for if I'm rotating around the z-axis, and again we need a concept of what is meant by an anti-clockwise rotation, so I get the positive direction. And it turns out that if you move x towards y, that is the correct direction. Now when you do this, this setup becomes this setup. So notice that well, the z won't change. Okay, z stays exactly the same. Anything that's on the z-axis stays on the z-axis, and same amount that it was before. But x used to be going in this direction. Now x is going straight up. So that's a jump in the y direction, isn't it? So x turns into a jump 1 in the y direction. And the y-axis that used to be going straight up is now going to the left here. That's the negative x direction. So if it's going to the left that way, that's the negative x direction. So when you put them all together, that we get this rotation matrix. And again, if I take out the last row and last column, because that's just step 1 in the z direction, that's the one that didn't change, you've got your rotation matrix, and you've got the minus in that position like you would expect in the top right. And here's why y is a little bit different. It turns out that the appropriate direction for anti-clockwise is from z towards x. Okay, from z towards x. And so when you do that, y stays the same, so that's not surprising. What used to be, let's do the x. What used to be the x direction now appears to be going over here. Well, that is sort of a negative z type thing, isn't it? That's going not towards us, but away from us. And so x is now going over there. That's in the negative z direction now. What was the z has turned into the x-axis now, and so that's a step 1 in the x direction. When you put them all together, it's that. But notice how, if I take out the y, because it's going around the y-axis, we've got this going on, and look, the minus sign has appeared in the bottom left, which is not, it is where the textbook said it would be, but it's not what we would expect with our rotation matrix. There's two reasons why what I've explained is indeed the correct anti-clockwise direction. And to understand that, we need to consider this system here, we call a step 1 in the x direction I, a step 1 in the y direction j, and a step 1 in the z direction k. And it turns out that if you do I times j, you're supposed to get k. If you do j times k, you're supposed to get I, and you've got this sort of cyclic system. So you're always turning x towards y, y towards z, z towards x. That's your anti-clockwise system, and that's your positive direction. It turns out that if you did j multiplied by I, you can try it on your calculator if you don't believe me, actually do 0, 1, 0 multiplied by 0, 0, 1 on your calculator. Apologies, j times I, so 0, 1, 0 times by 1, 0, 0, it should return 1, 0 minus 1. It will give you minus k, because j times I is the opposite direction. It turns out, no pun intended, that when multiplying vectors, it's necessary to consider direction as well when turning and rotating. Now, a completely different way of understanding which direction is positive and which one is anti-clockwise, you could instead set it up so that one of the axes is pointing in your face, and the other two axes have no real choice. They point in the direction that they point in, and then when you move x towards y and y towards z and so on, then you've got the appropriate directions. So this is one such situation. Suppose I was rotating around the z-axis. I want z to be coming out into our face. It's coming out the page. So you can't see the z-axis. It's coming straight up towards us. Now the positive direction, anti-clockwise, I think you can see quite clearly, anti-clockwise there. And notice that, I'll just do one of these and then I'll show you the result for the others, we used to have a step 1 in the x direction, and now when you rotate it just a little bit, it's got it shrunk a little bit in the x direction, and we've picked up a y component as well. This height here is sine theta, and this length here is cos theta. So that's why the 1, 0, 0 is now only cos theta in the x direction and sine theta in the y direction, and it doesn't come out the page at all. In the same kind of way, when we rotate this way, notice that our 0, 1 jump has picked up a horizontal component as well. This horizontal component here is sine theta, or rather I should say it's minus sine theta because it's going to the left, and this is cos theta up here. So our 0, 1, 0, our jump 1 up becomes a little bit to the left, and not quite as much up, just cos theta up, not the whole 1 up anymore. So when you put it together, when you put that with that, and of course the z doesn't change, you get this matrix here. In the same kind of way, remember when I was holding my sticks, if I held my sticks in such a way that the x came directly towards us, then the positive z-axis is over here. Now that looks a bit confusing, but remember how I was holding my sticks. If the positive x is coming towards our faces, then that's the positive z, and that's the positive y, and then this is our anti-clockwise direction. I'll let you pause the video if you want to see how it all fits together. Okay, and finally for our y, which is somehow different, this time if you're holding your sticks and you hold it such that the y-axis comes towards us, I didn't write that on, did I? Y towards us. So if you hold it so that y is towards you, then the sticks have no choice in how they're arranged. The x would be going that way, the z would be going that way, and this is clearly anti-clockwise. So that's another way of thinking about what counts as anti-clockwise. It's only anti-clockwise if one of the axes is pointing directly in your face, and then you've got a concept of what's anti-clockwise. Now everything I've just said could be skipped over. I've just tried to show you where these results come from, why they are true. Although to be honest, that's not the most important thing. You're going to do some questions from the textbook now, and hopefully you can do those. You can use the results that I just printed on page 145. That's not cheating. It is possible to just learn them. But I wanted to just show you where all these things come from.